In this lesson, we're going to take a look at the periodic table, some of the groups that are on the periodic table, and some trends that we see on the periodic table. Now, the very first thing to do with the periodic table is to split it in half. And I don't mean in half, I just mean into two sides. Okay, so this zigzag line I just traced, that separates the metals on the left from the non-metals on the right. And by metals, I mean things that tend to be good conductors, tend to be shiny, silvery things, and they tend to be malleable. And malleable just means when you hit it, it bends and deforms instead of shatters. The nonmetals have mostly opposite properties of metals. They tend to be brittle, so if you hit them, they break into pieces. They tend to be poor conductors, and many of them are actually gases at room temperature instead of the solids like the metals over here. Now, once we've separated metals from nonmetals, there is this one little group in between. So boron, silicon and germanium, arsenic and antimony, tellurium and polonium and astatine. These are called the metalloids or semi-metallics. They have properties that are in between metals and nonmetals. So metals are good conductors, nonmetals tend to not be good conductors. Metalloids are semiconductors. Under certain conditions, they make pretty good conductors. Silicon, for instance, is used in computer chips because it's a semiconductor. It's also a very brittle thing. You can smash it with a hammer and it'll shatter, but it is silvery and shiny like a metal. So they have properties that lie in between metals and nonmetals. Aluminum, sort of an interesting element. It is a metal. It touches the line, but it does not qualify as a metalloid. It's got definite metallic properties. And then once we've separated our metals from our nonmetals, then we can actually get into representative groups on the periodic table. Now remember, elements in rows on the periodic table have different properties. So hydrogen is a very, very reactive gas. As we move across the row, there's only two of them in here. We get to helium, which is a very, very non-reactive gas. Okay, and so the first period is sort of interesting. Remember, those elements only have one energy level that holds 2 electrons. So hydrogen has 1 electron in the first energy level, and it needs another one or would like to lose one, so that energy level was full or empty. And then helium has 2 valence electrons. It fills that first energy level, which makes it an incredibly stable element. It doesn't react. It just hangs out. Then we get into lithium, and it starts putting electrons into the second energy level. So remember, on the periods here, 1, 2, 3, 4, 5, 6, 7, they actually correspond to energy levels. Every time we get a new row on the periodic table, we're filling in a new energy level. In column 1A, okay, so A, I'm talking about these 2 columns and the last 6 columns. Those are our A groups. And when we're looking at A groups, the column number tells us the number of valence electrons. So everything in 1A has 1 valence electron, and everything in 1A except hydrogen is an alkali metal. And the alkali metals are primarily important because they are very, very, very reactive. You guys have probably heard of these. Lithium is used in all your cell phone batteries. Sodium, you guys, we get in table salt, sodium chloride. Potassium is a nice mineral. I think you guys have told me it's in bananas. Rubidium, yeah, we probably don't use that one very much. Cesium is actually how we measure time, vibrations of cesium atoms. And francium is so radioactive there's not very much of it on the planet at any given time. However, the rest of these we can actually get, and we can see how reactive they are. So I'm going to show you a little video that shows us the reactivity of these metals. So this is lithium, and you can see that it's so soft it can be cut with a knife. And that's true of pretty much all the alkali metals. They are soft, silvery metals. And you can see after he cuts that one, it's shiny silver like we think of when we think of metals. But it rapidly oxidizes or reacts with stuff in the air so that it turns back to this darker color. It's not stained silvery metal because that metal, that lithium metal, is very, very reactive. Of course, if you scratch off that coating, the metal is still there underneath. Now that color change is an example of a chemical change. Now this is sodium. They had it under oil to prevent it from reacting with the air. And just like before, you cut it with a knife and you get the nice silvery shiny place underneath. But you can see how rapidly that silver color went away. It reacts very quickly. This is potassium. It reacts even more quickly with the air than sodium. You can see almost immediately after being scraped, it's changing color, reacting with the air. We're not going to show you the rest of them in air, but I'll show you what they do in water. So this is going to be a sample of lithium in water. And what's cool about this is it's floating on top. So this lithium is reacting with the water, and you can see the gas coming off of there. That's hydrogen gas, and it's moving around a little bit. This is sodium in water. Again, same kind of thing. It's reacting with the water. It's producing hydrogen gas, and it's moving around quite a bit. So it's a little bit more reactive than the lithium metal was. It's producing a little more heat, and this is actually the reaction. It's sodium reacting with water to get us hydrogen, hydroxide, and sodium. So this hydrogen gas is actually flammable, and when we put in potassium, we can see that because it generates so much heat, it actually lights that hydrogen on fire. So we get some nice hydrogen reaction going on there as it burns. Rubidium is more violent yet. You'll notice that one didn't hang out for very long. Okay, so rubidium, throwing that in water, probably not a great idea. And finally, let's take a look at what happens when we put cesium in water. Now, cesium is actually got a low enough melting point that if you were to hold it in your hand, it would turn to a liquid, but holding it in your hand, bad idea. So as you can see, the most reactive metal is actually down here at the bottom of this column, and that's because as these atoms get bigger and bigger and bigger, the electrons get further from the nucleus, and so it's easier for them to do things, since these electrons, we'll learn later, are transferred away from these atoms. Then we move into the B group elements. The B group elements contain a lot of familiar elements you guys might know: iron, part of steel, nickel, copper, silver, gold, mercury, only liquid metal at room temperature, platinum, fairly expensive metal, zinc, used in galvanization. Oh, I guess I skipped 2A. We'll come back to those in a minute. This is tungsten. It's another B group element used in light bulb filaments. Titanium, very strong metal. Chromium, nice silvery one. Okay, back to the 2A elements. These ones are less reactive than the elements in 1A. So the alkaline earth metals here in 2A are a little bit less reactive because they do have one more valence electron. They have 2 valence electrons. You guys probably are aware of calcium. You need calcium. It helps you build your bones. Magnesium is also a pretty cool element. It's a metal, but you can burn this metal. If you light it on fire, it burns a very bright white. They used to use it in flash photography back when that was actually a big fire flash. It's also important in photosynthesis. Magnesium's in chlorophyll and helps photosynthesis occur. Then, like I said, we have the zigzag line separating the metals from the non-metals. And the first element in period 2 that's not a metal is boron. It's a metalloid, and everything in this column has 3 valence electrons because it's 3A. Aluminum is probably the one you guys are most familiar with. It's a fairly reactive metal, and 3 valence electrons. Then we get to carbon in group 4A, 4 valence electrons. Carbon is important in the chemistry of life. Sugars, fats, proteins, these are all built on carbon. So basically everything in you that is not based on water or is not water has some carbon in it. Then we have nitrogen here in group 5A. Nitrogen is a very, very common element. It makes up about 80% of the air you're breathing. You breathe it in, you breathe it out. You can't do a lot with it. But you do need some nitrogen. It's in amino acids and things. So plants actually use nitrogen in the form of nitrates, and then we get it from that. And so nitrates are fertilizers, if you've heard of nitrates before. Group 6A has oxygen and sulfur in it. Those are probably the 2 common ones you guys are aware of. Oxygen is a very reactive gas. Of course, we need that for fire. Sulfur is used in a variety of things, primarily sulfuric acid. And then we get to group 7A, which has got 7 valence electrons. And this group on the periodic table is very important. Just like column 1 is the alkali metals, column 7 has its own special name. It's the halogens. And these are the most reactive non-metals. But they do things that are a little bit the opposite of the metals. Now the metals, we're going to learn later, give away electrons. The non-metals would actually like to take an electron, because if you think about it, fluorine has 7, and if it had one more, it would look like neon, and the noble gases are stable. So if it could take 1 electron, it would be stable. Okay? And since fluorine is the smallest, littlest atom without very many electrons around it, there's not electrons there to push other electrons away, so it's easy for it to take one. So fluorine is actually the most reactive one over here, and so reactivity increases this way. So fluorine's the most reactive non-metal. Chlorine, you guys have probably heard of, reacts with sodium to make table salt. In fact, if you look on YouTube, there is a video of that reaction. Then bromine iodine and acetine iodine, you guys have probably heard of before as well. Then we have the last column on the periodic table, and the last column is called the noble gases. noble because they don't do anything, just like nobles. Okay, they sit there and they're inert. That is, they don't react. So helium doesn't react. It's got 2 valence electrons, and that fills the first energy level. But remember, the rest of these are all going to have 8 valence electrons because the rest of the energy levels hold more than 2. So neon, argon, krypton, xenon, and radon are the noble gases, and they do not react. They have a full outer energy level.